let's see what we have here. We will be trying to understand the concept of what we call binomial experiment. We will learn how to find binomial probabilities, and we would also learn how to find the mean, variance, and standard deviation of a binomial probability distribution. So the focus will be on binomial probability distribution today. Now, in statistics, we have something that we call a binomial experiment. The binomial experiment, when you look at this word bi, all right, the binomial experiment, bi means two, right? So two possible outcomes. So any experiment where you only have, so any form of experiment where you only have two possible outcomes, right? That falls under what we call binomial experiment. Now, in an example could be you flip a coin, you don't have any middle ground, it's either a head or it's a tail. Or in a multiple choice question, your answer may either be correct or your answer may be wrong. All right. Now, because binomial just have two possible outcomes, right? In statistics, we use the word success, so two outcomes. We use the word success and failure. Now, not in the emotional sense. Success just means that the outcome that occurred was what the experimenter was interested in. Sometimes we call it favorable outcome. And then a failure is an unfavorable outcome. Unfavorable outcome. So if, let's say, if the experimenter, you are tossing, so here you are tossing a coin 10 times, right? Now remember, each time you're going to have a head or a tail, right? So everyone a head or a tail, head, tail, head or tail, head or tail, head or tail, head or tail. Why did I write 10 times? It's too much for me, right? Head or tail, head or tail, head or tail, head or tail. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? Now, suppose it happened that the first time I had an head, right? Maybe second tail, then we get head, then we get tail, and then maybe tail again. All right. If the experimenter is, suppose I am interested in the heads, right? Suppose, actually no, let me write a tail to make my point clear. Suppose I'm interested in the tails. Then whatever I am interested in becomes my success. So in this case, my success will be the tails. All right. So I have 1, 2, 3, 4, 5, 6 tails. Right. So my success is the tails. And in binomial, you count how many successes you have, and that is the x. In this case, I could say x equals to 6 because I'm able to get 6 of what I am interested in. All right. So a success means whatever the experimenter is looking for occurred, and then a failure is like whatever they are looking for did not occur. Okay. Now, so note that in a binomial, you are looking for the experiment has only 2 possible outcomes. All right, so I gave an example here that when you flip a coin, it could be heads or tail. All right, now there are certain requirements for something to be a binomial. For example, it says each outcome should have a fixed probability. You see the example that I gave here? All right, a head, for example, has a probability of 0.5, right? So each time it should be 0.5. It should not be that from one point to the other, the probability should change of getting a head, right? And then the tail is still 0.5 in this case. So each time you perform the experiment, the probability of getting ahead will still be 0.5, irrespective of whether this is the first experiment or this is the 10th experiment, right? So they have the same probability of 1/2, no matter the number of tosses. And that's what we call that each trial or each outcome must have a fixed probability. Okay. Now, so let's quickly look at some of the key areas of probability distribution. Binomial distribution, sorry. First, there should be a fixed number of trials. Now, when we say the number of trials, actually we mean something like your sample size. So usually we use n to represent the number of trials. How many times is the experiment repeated? It's the same as if they carry a survey, how many people were in the survey, right? Becomes your n. Secondly, each trial must be independent. We learned about independent, the early part of chapter 3, when we were looking at dependent and independent event. We said two events are independent if the occurrence of one do not affect the probability of the occurrence of the other, right? So in this particular case, when it says each trial is independent, let's say you toss in a coin 10 times, right? The result that you get, let's say in the first one, should not influence the result you're going to get in the second, and so on and so forth. All right. So each trial must have each trial must be independent of the other. The third thing is that I've already said about it, that there's two possible outcomes, only two possible outcomes, only two possible outcomes. And then the probability of a success should remain the same. Probability of each outcome should remain the same from trial to trial. All right, and X is the count of the number of success. Just like, remember how I counted the number of heads, tails, sorry, in the other problem. As we start taking questions, this will be much clearer to you. So in any binomial kind of question, you should have 4 variables that you need in the question. All right, you need these 4 variables. The n is the number of trials. In other words, what is the sample size? What is the sample size? How many people were in the survey if it's a question that involves survey? Probability, p, we use the lowercase p to represent probability of success. So that's the probability of what the experimenter was looking for. All right, and then we use the lowercase q to represent probability of failure. Now, note that q is 1 minus p. Q is 1 minus p. And then we use x to represent the count of how many successes you have. So if I'm interested in the tails when I toss a coin, how many tails did I have when I maybe toss a coin 10 times? So that is your x. Okay, and we call that x the binomial random variable.
All right, can you just scroll back up just for a small second?
Okay, this one or before?
Yes, that one.
Okay. All right, so whilst I'm here, I want you to think of binomial like a big circle, and now the circle has only 2 parts, the success part and then the failure part. success and failure doesn't mean a bad thing here. Success just means that whatever the experimenter is looking for occurred, and failure means that whatever you are looking for did not occur. All right. So the probability of success, we use p lowercase p, and then probability of a failure we use lowercase q, but q is the same as 1 minus p. So if this is 30%, this will be 70%, so on and so forth.
Okay, thank you.
Okay. Now, so let's take a question here. Actually, this one just wants us to be able to read a question and specify what is the n, what is the p, what is the q, and what are the possible values of the x. Okay, so when you are reading a binomial question, it will not tell you, hey, I'm binomial. No, right? But it comes from implication. All right. So they're not even going to tell you the two. They're not going to tell you the two outcomes. But when you read a question and it feels like we have only two possible things. All right. Let's read this question. It says that in a sample, in a surgical procedure, a surgical procedure has 85 chance of success, which means that if this circle represents all the procedures, then there could be a success, or there could be, we could have a success or we could have a failure. And they're saying that that you have 85 chance of a success, right? So this is 85%. So we expect this roughly to be 15%. So your P is 0.85, your Q is 0.15. If you cannot see it easily, sorry, I wrote 0.15 or 18. If you cannot see it easily, you can do 1 minus 0.9. So this is 0.15. So each time you are reading the question, they may give you only one side of it. So they say, so if this is the procedure, they will say that, well, they give you a chance of success, so you know that the other portion will be the chance of a failure. Now, the question indicated that what we have 8 patients, right? So your n is 8. Number of people in the sample is 8, or the repetition is 8. And we assume that each patient is independent of the other. All right. So in this question, the x is going to be, ask yourself, the experimenter is interested in the successful surgeries. All right. So for each patient, the outcome could be successful surgery or a not successful surgery. All right, which we are calling this failure. All right. So here, when I say a failure, it means the surgeries that were not successful. So in this case, it could happen, but we are only interested in here. So it could happen that there was, out of the 8, there was no success. It could happen that there is 1 success, 2, or it could happen that all eight surgeries were successful. So in a binomial, your x could range from 0 to n. Your x value can range from 0 to n. Okay. So these are the results. Your n is 8, that's the normal trials. Your p is 0.85, which is the probability of a success. Your q is 0.15, which is the probability of failure, and x could be any one of these numbers. Now, for most problems that you are going to have, most binomial problems could ask you to either find a mean, standard deviation, variance, standard deviation, or it could ask you to find probability. So I want to start with the easiest one, how to find the mean, variance, and standard deviation. As far as the binomial questions are involved, if it says you should find a mean, all you got to do is to take the n and multiply by p. N times p gives you the mean. If the question says find the variance, right, all you got to do is to do n times p times q. And that is a variance. If the question wanted to find the standard deviation, take the square root of the variance, or take the square root of n times p times q. Right, we know this from our previous classes that the standard deviation is the square root of the variance. Okay, so let's look at these tiny questions that I see here. It's not too clear on your screen, but I can write it out. They said there are 75 trials, so n is 75. And then they said that the probability of success is 0.58, which means that P is equals to 0.58. Now, it implies that Q will be 1 minus 0.58, that will be 0.44. So if the question says, what is the mean? All we got to do is to take the 75 and multiply it by the P.58, and that will give us 43.5. And then that's it. That's the mean. If the question says find the variance, if the question says we should find variance, all right, then all we're going to do is take the n 75 times the p 0.58 times the q 0.44, and then the answer you get here, I think that gives you 18.27. That gives you the variance. This is the variance. All right, this is the variance. This is the mean. This is the variance. If it asks you for standard deviation, then you're going to take the square root of the variance. All right, so let's take another example. All right, so in the second example, the question indicated that, so Pickless, Pennsylvania, about 56% of the days in the year are cloudy, which means that there is some implication they are not telling you. So they're looking at cloudy days in a month, and then they're looking at the non-cloudy days. Specifically, the experimenter is interested in the cloudy days. That is the only reason why they give you information about cloudy days, and they did not give information about the non-cloudy days. So they're telling us that the probability of a success is 0.56 because we know that they were focusing on the cloudy days. Now they want us, well, we should then know that Q, which is the probability of a non-crowded days, will be 1 minus P. So that is 1 minus 0.56. That is 0.44. In other words, if I have a circle and I break it into two, and one portion is 56%, the other portion should be 44% in order to give you 100, right? The whole circle is 100%. Okay, so we have our P and then we have our Q. We have our P, we have our Q. Now we need the N. Now they said that that person was examining the days during the month of June. Now the month of June has how many days? So this is your N, the month of June. So your N is 30 days in the month of June. So now that we have this information, question says we should find the mean. So how do you find the mean? You take the N, and then you multiply it by P, N times P. So the mean will be 30 times 0.56, and this says it gets 16.8. So the mean is 16.8, or we could write mu equals 16.8. Then the variance. So here the variance will be n times p times q, right? So variance is n 30, p 0.56, q 0.44. So that gives you 7.4. So the variance sigma squared is 7.4. Then it says we should get the standard deviation. Now, standard deviation, it's the square root of what? The n times the p times the q. Now, note that we've already found the variance, so we could just actually take the square root of the variance and we should still be okay. All right. So here, for example, we can just say square root of 7.4. And that will give you 2.7. So sigma, which is the standard deviation, is 7.4. So sigma equals 2.7, sorry. So that's how to find the mean, the variance, and the standard deviation. So those are one set of kind of problems that you're going to be having in your online assignment. So your online assignment may look like something like this. All right. So this says that you have a test consists of 100 multiple choice questions. Now, sometimes because they say multiple choice questions and it says there are 5 possible answers and only one is true, all right? So they're looking at those questions that you get correct and then questions that you get wrong. All right. So for each question you may have correct answer or you may have a wrong answer for each question. All right. Yeah, we'll talk about it. Let me get this done. So we could have a correct answer, correct, or we could have a wrong thing, right? So here in this particular case, right, its probability of a correct is 1 out of what? 5, which is like 0.2. Right, and then probability of wrong, which is Q, right? Probability of getting the question wrong. So out of every one question, there's only 1 out of 5 that is correct, and their Q will be 1 out of 4 out of what? 5. Because when you add it, you're going to get 5 over 5. That gives you 1. All right, or this will be 0.8, which is 0.8, or you could do 1 minus 0.2. That will still give you 0.8. So P is this and Q is that. This is P and this is Q. Okay, so here what we would do then will be to say that how many questions were there? N is 100, right? N is equal to 100. So all we do to say what does it mean? Mean is gonna be 100 times the probability 0.2. 100 times 0.2, that would be 20. Then they want a standard deviation. So standard deviation sigma is the square root of 100 times 0.2 times 0.8. I don't know what this will give you. Someone do the calculation, let me know. Could someone do the calculation for us so I could know it? Okay, so you had 4. Okay, you took the square root already, right? Okay, so we would choose the D. Is it D? So this is the right answer, right? If okay, good. So that's how some of your homework problems should look like. Now the next set of so this is the same kind of thing. Just let me. Oh, by the way, the mean sum deviation is not that bad. Okay, so let me now. The next set of questions you may have will ask you about probability. All right. If you ask you about probability, definitely it wants you to use a probability formula. And this is a binomial probability formula. Doesn't look so cute. Looks so nice, right? All right. So some of you that have taken some math before, probability of x, where x is a binomial random variable, it's n combination c, then times p raised to x, then times q raised to n minus x. You know about this already. You know what p is. You know what x is. You know this about p, q, x, n. You know them. What you don't know is this combination, right? The combination is this portion of it. All right. In math, when we write n with that, it's called n factorial. Now, factorial is a series of multiplication. Let's say you have 5 factorial. It's a shorthand for a series of multiplication like 5 times 4 times 3 times 2 times 1. So it starts with a number and ends at 1. A shorthand for a series of multiplication. We start with the number and then keeps decreasing by 1 until we reach 1. Right? So if you have 3 factorial, it means 3 times 2 times 1. If you have 100 factorial, then it's 100 factorial. Ooh, so that's 100 times 99 up to times 1. You're going to end at 1. So this saves a whole lot of space, right? Save a whole lot of space. Okay. The good news is that we are not going to use this formula because in this class, I try to make your life a little easier by by using the TI-83 or TI-84. So this formula has been already programmed into the TI. So when you're looking for a probability for binomial, we're just going to be using our TI to do those problems. All right. At the same time, though, whether you're using TI or whichever method you're using, you need to know the N, the P. Usually the TI don't ask you for the Q, but you need to know your X. All right. So why don't we look at questions that we can use the TI to do? Now, in the TI calculator, there are 2 functions in there that we'll be using. One is called the binom PDF. PDF means probability density function. And then the other is called binom CDF. CDF means cumulative density function. Now, probability density function gives you the probability at 1 point. So this gives probability at 1 point. Right? At 1 point. So identify the P there, the P here as like 1 point. Now, the cumulative CDF gives you the probability from, so this gives you probability from 0 to the X value. So if somebody writes something like this, let me write it out. Suppose give me a second, let me enlarge this a bit. Okay, do I have the space? Okay, so suppose we write maybe something like binom PDF. I put 10 here, I put 0.6 here, and I put 2 here. It means this one is going to give me the probability of 2 only, because the X is the one that comes at the end. This is the X value. This is the N, this is a P, this is the N. So the format N comes first, followed by P, followed by X. But if someone writes binom CDF of the same thing inside, 10.62. What the person mean is that we have probability of 0 plus probability of 1 plus probability of 2. So CDF means cumulative. So the number here is not just one value, it's from 0 to the number. So in a CDF, this is x equals to 0, x equals to 1, x equals to 2. But you only write a 2. But for PDF, the 2 is just what you see there. This is like a point. This is cumulative.
Quick question. How did you get 2 again for the bionom?
I just made an example. I just pulled an example from my head.
Okay.
Okay, but let's look at an actual question. So let's take this actual question that I'm going to show here. Now you don't have this question on your slide, but at least like one of your online assignment questions that you may have later on. Okay, so let's read this question. Question says that in a recent survey, 64% they favor building the police substation. All right, so it means that we are looking for each person. If it was a survey, someone asked, do you favor building or you oppose, right? So we're looking at favor and oppose. So this is a binomial. So even though they have not told you about the other side of the story, the oppose is implied. Especially, they're just telling us that they focus on the favor. This is what the experimenter focused on the favor. Because they were focusing on this, they found out that the P is 0.64. Now, if 14 neighbors, so your N is 14, your N is 14. And it says find probability, right? That exactly 8. So your X is 8. So because this is just exact, we just want this, they want us to find probability of 8. So how do we find this? We are not going to use the formula. We're going to use our TI. So in order to use the TI, we're going to do, in this case, because we're looking for one number, we're going to do binom PDF of N comes first 14, P comes second 0.64, X comes second 8, and this 8 is just a single 8. All right, so but where do you find the binom function? That's where I'm going to take you now. So where you find the binom function is true, you're going to do second. So in your calculator, you're going to do second, and then you select vars, V-A-R-S, second vars. Then you look for, you're going to scroll down until you find binom PDF. All right, so let me pull my calculator. So my calculator, let me power it on. Why is the power not coming? Okay, clear. So you do, let me see if I can show the key press. That's the LCD. And then the key history. So I want you to see what I'll be pressing. So that's why I put this over there. So you go to second, right? And then you press VAS, V-A-S. Then you scroll down looking for, okay, so in this case it's a binom PDF, right? So I enter that. Now, if you have the TI like I have here, it will ask you for trials. trials is the same as your n. All right, the trials is the same as your n. The p is your probability, and then so in our case, let me see. In our case, the n. Let me quickly see if I can pull my n. All right, so in our case, the n is 14. So we're going to put in the 14, 1, 4. Then the n is 14. The p is 0.64. The x value is 8. And then we say paste. Now, for those of you that have TI-83, when you click on the Binomial PDF, it will just bring you this screen. All you got to do is just to type in the 14,0.64,8, then close parentheses. All right. So the TI-83 do not give you the screen that you saw before, but it will just bring you here. Binomial PDF. You put in. Always n comes first, p comes second, x comes third. All right, n is first, p is second, x is third. The order is very important. So once you have that, you press enter, then it will give you the answer that we were looking for. All right, so let's see here. See if you could, I could see my own answers. Okay, so looks like that's this one. Excellent. All right, so let's look at another example. You are not no, it's not the normal. That one should also have Binomial's PDF. So the place you see the normal PDF, you have to keep scrolling down or look for the Binomial PDF. Okay, so here sometimes you don't see the P, but it is implied. All right, so it says assume male and female births. So this is giving you some coded information. Male and female death. What is the probability of, let's say, in a male? Someone to put on the screen. Probability of, excellent. So here P is 0.5, but they've not said it. It's based on how the sentence is written. So the P is 0.5, right? And it says find the probability of, so they want you to find x equals 9. So let me see how I wrote it 9. X is equal to 9. So we are looking for probability of 9. That's what we are looking for, right? What is our n? They said there are 10 boys, right? So n is equal to 10. So this question, because we are looking for just exact, so probability of 9 will be binom PDF of 10, which is your n, p is 0.5, your x is 9, and then you just write the answer. So let's see, let me put my power on clear. So we have second vase, and then go to binom PDF, enter. So my n is 10, my p is 0.5, my x is 9. I will say paste and then enter. So that is 0.00976. Okay, so the answer should be D. Very good, very good, very good. All right, now let me show you the next question. Oh, same thing. Okay, so yeah, let's look at this one. Find the probability 2 or fewer, but let's start from the top. All right, so they're looking at this age group, those that never married, 40. So they are focused, so they're looking at never married and maybe married, right? Two options. So never married, P is 0.4. By the way, let me tell you this, since I'm looking at this question. In your homework problem, there is a question that says, like never married, but it says find a probability, let's say 2 or few married. Always this sentence should match this sentence, the probability sentence, right? If they said find a probability 2 of you are married, then you are not going to use 0.4, you're going to use, so here Q will be 0.6, right? The marriage is 0.6. So if the question was about married, then you have to use the probability that goes with married. All right. In your homework problem, there's one tricky question, just one, I think, that they give you never married, but then they ask you a question about married. So just take note of it. I just want to stress on that. But in this case, the probability is never married, and they are asking us about never married, so we are good. So P is 0.4, N is 10, because it said 10 women, and then X is what? 2 or fewer, meaning 0, 1, 2. That's the meaning of 2 or fewer, which means that they want us to find probability of 0, find probability of 1, find probability of 2, and then add the answers. But we know that anything that starts from 0, 1, 2 is the same as the, and as long as it starts from 0 up to 2, is the same as the cumulative. So this is the same as the cumulative of x equals to 2. So this question, instead of doing 3 separate things and then adding them, I can just do only one thing. I can do, for example, binom CDFs. So I write 10, I write 0.4, and I write 2. So as long as you use the word C, you choose the word C here, this 2 means from 0 to 2. So the 2 here, the 2 over here means P of 0 plus P of 1 plus P of 2. So that is what the job of the C is doing for you. All right, so these are questions that all you got to do would just be to just go to CDF and then answer it. All right, so let's do it. Yeah, so you got the answer. Okay, great. All right, but let me see. So second verse, then I go down to binom CDF. Actually, the same information, 10.4. Then I have 2 here. Say paste CDF. Bingo. Beautiful, beautiful, beautiful. So this is our answer, like we got. That's our answer. Okay. So those are the kind of questions that you're going to have. Now, sometimes though, let me say in general, let me say this in general. All the questions can be answered with PDF, any question, PDF, right? So even if you are confused about CDF and you know how to do PDF, you should be able to answer any question, all right? It just sometimes may take a little longer, that's all. Okay. So lower and upper bound. Wait, I'm not too sure of that. Are you in the normal? Because the normal asks lower and upper bound. I don't think the binomial should ask lower and upper bound. So check if you are in the normal. Make sure you select binomial, either PDF or CDF.
Can you go back to the one question with CDF for a second?
CDF or PDF?
CDF.
Oh, this
The
one.
one. Yeah, that one. Just one sec.
Okay.
Thank you.
All right. Okay. All right. So I'm not sure, Sophia, what is happening with your calculator. Sorry about it. Okay. So I wish I could have answered one more question. Let me see if I have something hiding somewhere that we could look at. I just have one. Exactly two. No, sometimes the question may say at least, less than. Okay, so I know my time is almost gone, but if you have a question like this that says less than 8, all right, less than 8 means 0, 1, 2, 3, 4, 5, 6, 7, 8. So if you're using PDF, it will take you a long time. As long as the value is from 0 to the number, you are better off just to do what? CDF. All right. Okay, I just trying to point some few things. Okay. Now, yes, Olivia. Oh, I'm sorry. It says less than 8. Why did I choose? What actually it should be 8. Thank you. Thank you so much. You are so valuable member of this class. Great, great, great. If it says my time is gone, but let me mention this. If the question says at least, right? At least means that from that number going. So at least 2 means 2, 3, 4, 5, up to how many values there are. Actually, this case, there are just 4. So 2, 2, 3, 4. All right. So you can do PDF of 2, PDF of 3, PDF of 4, and then you could answer that. All right. Now, when would the assignment be due? So we can